Hello friends, this is the second part of the video for the exercise 1.5. In first part, I had explained operations on rational numbers and all solved examples. And now in the second part, I will explain exercise 1.5 all examples. I will give the link of that first part in the description box of this my video as well as in the comment section. Okay. Also, in first part, I will also give the link of this video in that description box as well as in the comment section. Now, let us start exercise 1.5. First question. Classify the following numbers as rational or irrational. Okay. Now, the first answer here. Two minus root of 5. Root 5 is an irrational number and 2, this is a rational minus irrational. Here it is a irrational. Okay. Therefore, I will write 2 minus root of 5 is irrational. Because root of 5 means you will get 2 point something up to the non-terminating, non-recurring. And if we subtract it with the 2 minus, then you will get minus point up to the non-terminating and non-recurring. And therefore, 2 minus root 5 is a irrational number. Next, what about here? Here, in bracket, 3 plus root of 23 minus root of 23. We evaluate this bracket, plus root 23 minus 8 cancel, and you are getting the 3. And what type of this number is the rational number. Next, 2 into root 7 upon 7 into root 7. Here what's happening? This root 7 and root 7 get cancelled and you are getting 2 upon 7. And this number is a rational number. CP rational number. Next, 1 upon root 2. Now we rationalize the first of all denominator, that is multiplied n and d by root 2. Okay. And then simplify. That is root 2 into root 2. You are getting 1 upon 2 into root 2. That is a root 2 is nothing but the 1.41 and up to dash up to the infinity. If we divide it again here by 2, again you are getting the irrational number. Therefore, this is also irrational number. Irrational number. Okay. After substituting the value of root 2, and if we divide it by 2, again you are getting the non-terminating and non-recurring. Okay. Already pi is a irrational number. If you multiply it, then again that will be also irrational number. So irrational number. Okay. Now the next question. Simplify each of the following expression. First is 3 plus root 3 2 plus root 2. Okay. Now multiply these 3 to this whole bracket, 2 plus root 2. Okay. Next, this root 3 into in bracket 2 plus root 2. Okay. Next multiplication, 3 into 2, 6, 3 into root 2, 3 root 2 plus root 3 into 2, 2 root 3, and last root 3 into root 2. Okay. Now the next, here is a 6. Again, there are no like terms. Therefore, we will write here 3 root 2 plus 2 root 3, and again root 3 into root 2. You are getting root 6, and hence the answer 3 plus root 3 into 2 plus root 2, that is equals to 6 plus 3 root 2 plus 2 into root 3 plus the root of 6. Okay, so the answer. Next example, in bracket 3 plus root 3 into 3 minus root 3. See this here. 3 plus root 3 into 3 minus root 3. What is here? A plus B, A minus B. And here by using that formula, here 3 square minus root of 3 bracket square, which is the formula. Here we are using A plus B into A minus B is equals to A square minus B square. Okay. And this equals to 9 root 3 square is 3, and here that is equals to 6. Therefore, we will write the answer 3 plus root 3 into in bracket 3 minus root 3, and that's equals to 6. Okay. Next example. Next, in bracket root 5 plus root 2 bracket square, root 5 plus root 2 bracket square is equals to root of 5 bracket square plus 2 root of 5 into root 2 plus root 2, and it's a bracket square. Root 5 square means what? 5 plus 2 root 5 into root 2 root 10, and root 2 square means what? We are getting 2. What is next? 5 plus 2, 7 plus 2 root 10, and hence the answer root 5 plus root 2 whole bracket square is equals to 7 plus 2 root 10. This is the answer. Next problem. Again here, in first bracket root 5 minus root 2 into, in second bracket root 5 plus root 2, root 5 minus root 2, root 5 plus, and therefore here their multiplication is a root of 5 bracket square minus root 2 bracket square. Which is the formula? The formula is a minus b into a plus b, and that's equals to a square minus b square. Okay, what's the root 5 square? It's a 5. Root 2 square is a 2. 5 minus 2, you are getting 3, and therefore the answer is root 5 minus root 2 into root of 5 plus root 2, and that's equals to 3. This is the answer. Now the next problem. Next question. Recall, pi is defined as the ratio of circumference, say C, of circle to its diameter, D. That is, pi is equals to circumference upon diameter. This seems to contradict the fact that pi is a irrational number. How will you resolve this contradiction? Yes, we can resolve it. When we measure with the scale or the tape, at that time we get the approximate value of circumference as well as the diameter, and that is why pi can be approximately represented as a quotient of two rational numbers. As a matter of mathematical truth, it is irrational. Okay, now with a scale, okay, with a scale we get only an approximate rational number, okay, as the result of our measurement. Okay, as a result of measurement. That is what type of the measurement you are using, and we get the approximate. What are that least count of that measurement? That is why that is why pi can be approximately represented as a quotient of two rational numbers. Rational. Okay. Because pi is the ratio of circumference upon diameter. Therefore, as a as a matter of as a matter of mathematical as a matter of mathematical truth, it is irrational. Okay, it is a irrational, and this is the answer. Now the next problem. Now represent a root of 9.3 on the number line. I will write this construct, how to draw the construction steps of this construction. Okay, now the first step. Okay, draw a segment of 9.3. Okay, 9.3 units on the number line. Next step, let capital A represent capital A represent 9.3. Next, extend it by 1 centimeter. If you have taken it is a 9.3 centimeter, then extend it by 1 centimeter. Okay. Next, show the point 10.3 upon 2, and that is equals to 5.15, okay, by, on the number line, on the number line, okay. Next, with O as center, with O as a center, and the radius with O as a center and radius 5.15 centimeter, okay, 5.15 centimeter. Draw a semicircle semicircle. Next, 6. Draw AB perpendicular to OA, okay, AB perpendicular to OA to cut the, hear me, cut the semicircle at B, okay, to cut the semicircle at B. Next, 7. The length AB is a root of 9.3 centimeter. Okay, it's the root of 9.3 centimeter. Now see these the steps. Okay, draw a segment of first 9.3. This is the rough sketch. Okay, I will draw the first 9.3 up to this, and this point is treated as, okay, this is the OA, and it is 9.3 centimeter, the first one, okay, and the point is here A. Next, extend it by 1 centimeter. Now extend this up to the 1 centimeter, and suppose that the point is here, D point. Then take the midpoint of this total, that is at 10.3. This total will become total will become 10.3 centimeter. Now take the midpoint of this CD and treated it as a O. Okay. Then draw the semicircle. This is the sketch. It is my hand sketch. It is a rough sketch. Okay. Draw the semicircle with O as a center. Okay. Next, draw the perpendicular through this point. If we draw the perpendicular, which is point A, and it intersects this semicircle at the point B, and therefore this AB is nothing but 9.3 centimeter, or it is a 9.3 unit. If you take it is with centimeter, then you can treat as it is a root of 9.3 centimeter. Okay. Here this distance. Okay. You can see this. First of all, draw the 9.3, which is the AC. Extend up to the 1 unit, whatever that you are taking. If you are taking it's a centimeter, then treat as a centimeter. This is the root of 9.3 unit. Okay. Just I have taken it is centimeter. Then take the center O with the CO as a radius and draw the semicircle. Again, draw the perpendicular through the point A. It intersects the semicircle at the point B, and this is nothing but the root of 9.3. Okay. Next problem. Now the question number 5. Rationalize the denominators of the following. Now the first question, 1 upon root 7. Again I will write here, multiply N and D by root of 7. Okay. If you multiply with the root of 7, then to the denominator you will get root 7 into root 7, 7, and that's why we are multiplying. Therefore 1 upon root 7, that is equals to 1 into root of 7 upon root 7 into root 7. What is the multiplication? 1 into root 7, which is the root 7. Root 7 into root 7 is a 7, and therefore here we are getting the answer root 7 upon 7. The denominator is a rationalized, or that is 1 upon root of 7. Okay. Now, next problem. Again, next rationalize the denominator. 1 upon root 7 minus root 6. Multiply n and d numerator and denominator by the conjugate part of root of 7 minus root 6. What is that? Root 7 plus root 6, and therefore 1 upon root 7 minus root 6, and that's equals to 1 upon root of 7 minus root 6 into root of 7 plus root 6 upon root of 7 plus root 6, and that's equals to 1 into root of 7 plus root 6 is a keep it as it is. Okay. And what about here? A minus b into a plus b. Then here you will get root 7 bracket square minus root 6 the bracket square. And here you are getting root 7 plus root 6 upon 7 minus 6, and that is equals to root of 7 plus root 6 upon 1, and hence the denominator is a rationalized. Therefore, write the answer 1 upon root 7 minus root 6, that is equals to root 7 plus the root 6. Okay. Answer. Now the next problem. 1 upon root 5 plus root 2. Here again multiply n and d numerator and the denominator by the conjugate part of root 5 plus root 2, which is the root 5 minus root 2, and therefore 1 upon root 5 plus root 2, and that's equals to 1 upon root of 5 plus root 2 into its a conjugate part root 5 minus root 2 upon root of 5 minus root 2, and their multiplication 1 into root of 5 minus root 2, that's equals to root 5 minus root 2 upon a plus b into a minus b. Then here we will get root 5 square root 2 square, and that's equals to here root of 5 minus root 2 upon 5 minus 2. Okay, and therefore here that is equals to root 5 minus root 2 upon here 3, and therefore 1 upon root 5 plus root 2 is equals to root of 5 plus root 2 upon 3. Okay. So here minus sign. 5 minus 2 upon 3. Now the next problem. Again 1 upon root 7 minus 2 multiply n and d by the conjugate part of root 7 minus 2, which is the root 7 plus 2, and therefore 1 upon root of 7 minus 2, that is equals to 1 upon root 7 minus 2 into multiplied n and d by root 7 plus 2. Here root 7 plus 2 upon root of 7 plus 2, again 1 into root 7 plus 2, root 7 minus 2, root 7 plus 2. Therefore here you get root of 7 bracket square minus 2 squares. Okay, and here root 7 plus 2, root 7 square is a 7 minus 4. Okay, and therefore here 7 minus 4 is a 3, root 7 plus 2 upon 3, and therefore 1 upon root of 7 minus 2 is equals to root 7 plus 2 upon 3, and this is the answer. Okay. And in this way we have completed this exercise 1.5. I will see in the next video. Till then, goodbye.